Why do so many people hate math? For a mathematician, hearing someone say, "I hate math," is like hearing someone say, "I hate flowers. Flowers are ugly." But we all know flowers are not ugly, and neither is math. Those who love it say math is a beautiful, delightful, and profound language that expresses life. Not convinced? Mathematicians would love nothing more than to convince non-believers just how beautiful math is. And one mathematician in particular is trying to do just that.
The subject is clouded over with so much technicality and complicated symbols, but underneath it all are these beautiful ideas.
That's Stephen Strogatz, professor of applied mathematics at Cornell University and author of Infinite Powers: How Calculus Reveals the Secrets of the Universe. So, what is calculus, and why is it beautiful? And how in the world does it express life?
The claim is that when we do science, especially physics or astronomy, we see patterns in the world and patterns in the universe, the way that the planets move. These are familiar things from everyday life. We know that the sun rises and sets every day. We know that it takes the Earth 24 hours to spin around on its axis. There are a lot of things about the natural world that are very mathematical, that obey consistent numbers. And this was known to all ancient people who plotted the calendar based on it and who could predict eclipses. And so astronomy was one of the first subjects to be mathematized. In other words, people were able to find numerical and geometrical patterns in the way that things changed from day to day.
Calculus, as you may have guessed or already know, goes way beyond simple arithmetic and geometry. Those are great for counting sheep or calculating taxes, but are inadequate for mapping the complexities of life.
If you live in the world where you're using very practical things like numbers to keep track of how many sheep you have if you're a farmer, and you know some basic information about shapes, things about straight lines and areas, like you're a surveyor and you want to measure how much area someone has in their field, how much land, so that the king can decide how much to tax a person. Those are the earliest parts of math. That's arithmetic and geometry. But at some point, there came to be a need to understand things that went beyond shapes with straight lines for their boundaries. Like you could have, the most clear example would be a circle, which has a round shape, the roundest shape you can imagine. And even the problem of finding the area contained within a circle stumped all the ancient mathematicians.
A guy named Archimedes figured out how to find the area of a circle way back in 250 BC while he was cutting up a pizza one day. Well, not actually, but you could do this at home if you want to recreate what he did.
Think about a big pizza, like say an 18-inch pizza, and you want to know how much pizza is that really, as far as like square inches of pizza. Square inches works best for square shapes. But if you have a round shape like a pizza, how are you going to measure exactly how many square inches that is? So all of us learned a formula in high school. The teachers made us memorize a formula that the area of a circle is pi r squared. And pi is that weird number that we all had to memorize that's around 3.14. And it was hard to understand. Why is the number 3.14? Well, all of this is the beginning of calculus, to figure out the area of a curved shape like a pizza.
Take your pizza and cut it into 8 slices like you normally would. But then line the pieces up on your cookie sheet side by side so that you create roughly a rectangle. Only it isn't exactly a rectangle. It's more like a parallelogram. Remember those from geometry? You know, like a rectangle but with slanted edges at either end. Now cut one of those ends in half and place one half on the other end of your pizza, and voila, you have a rectangle. Okay, your pizza rectangle has scalloped edges, but if you were to cut your pizza slices really, really thin, the long edges of your rectangle would be straight. And that's what calculus is, using infinity or really, really thin pizza slices to solve a problem.
It was a great discovery because he knew that he could find the area of a rectangle. That was an easy thing that people already knew how to do, just the length times the height. But this meant that he could, by using that formula, figure out the area of the original pizza. And so this kind of reasoning, when he took it to the limit of infinitely many slices, now all infinitesimally thin, gave him a perfect rectangle, and then with this brainstorm of an idea, a really amazing thought to take an infinitely thin sliced pizza, he could get the area of a circle perfectly.
Strogatz says the beauty of calculus is that it takes one really huge problem and breaks it down into much simpler ones. For example, calculus made the astronomically difficult task of getting someone on the moon possible.
An idea that was very important in calculus was the idea of calculating a speed at an instant. Picture yourself in a car, and you're driving along, and you look at your speedometer. At every moment, it says something. It tells you you're going 53 or you're going 62. It seems to know your speed at every second that you look at it.
And what does it mean to measure a speed?
It means I have to figure out how far did I travel in a certain amount of time. Like we say, I went 53 miles in 1 hour. But what about if you're only driving for a split second? Because the speedometer can figure out a speed for that too. And it would see that you've advanced by a tiny distance, like a little fraction of an inch over a very short time interval, a tiny fraction of a second, and it still can calculate a speed for that. And so if you imagine taking this process to the extreme of going an infinitesimal distance over an infinitesimal amount of time, that's the idea that calculus calls the derivative. That's the concept of an instantaneous speed.
Strogatz says calculus is like dividing 0 by 0 to get an answer that actually means something. And the mind-boggling thing is that this concept works. It's what makes space travel possible, and even cell phones with the electromagnetic waves that travel through space. But don't worry if none of this makes sense, because Strogatz didn't write this book for mathematicians.
Who I'm really writing for is the person who's always been either afraid of math or thought it was a bit pointless or just boring, and who may have some curiosity because they hear people saying, well, math is beautiful or math is elegant, and you feel like you're missing out if you don't know it. I mean, I've always felt that way for, in my case, say something like opera. I don't really get it. When I hear it, I hear people singing very theatrically, and I feel like, oh, it's so over the top, and I know that I'm missing something. That the great pleasure and the poignancy of opera that gets people weeping with passion at hearing these great arias, it's lost on me because I don't really know what's going on. And so I know that I'm missing something wonderful, and I wish I understood it. And you could say, well, does that help me pay the bills? No, it's not for that. It's for my soul. This is for your soul. There are things you have to do in your life because they're good for your soul. And I think understanding opera would be one. I think understanding calculus is one.
As Strogatz says, you don't have to be a mathematician to appreciate the beauty of calculus, but learning about it might go on your bucket list. You can read more about how calculus reveals the secrets of the universe in Steven Strogatz's new book, Infinite Powers, available now. And you can learn more about all of our guests by visiting our website at viewpointsonline.net. Our writer-producer this week is Polly Hansen. Studio production by Jason Dickey. Our executive producer is Reed Pence. I'm Marty Peterson.
Viewpoints returns in just a moment.
May is American Stroke Month, and while not all strokes can be prevented, up to 80%, including recurrent strokes, may be, with a few changes, like not smoking, eating healthfully, being physically active, and maintaining a healthy weight. People who've survived one stroke are at a higher risk of having another, according to Dr. Mitchell Elkind of Columbia University.
About 1 in every 4 stroke survivors will have another one. The best way to reduce your stroke risk is to live a healthy lifestyle and work with your doctor on a prevention plan. Also, ask your doctor if a daily aspirin or other medications for secondary stroke prevention are right for you.
More than 116 million people in the U.S. have high blood pressure, and fewer than half have it under control, putting them at increased stroke risk. Nothing causes more strokes than uncontrolled high blood pressure. Learn more at strokeassociation.org/stroke month.
Hi, I'm Diane Guerrero, and while orange is still the new black, oranges and fresh fruit help nourish communities and provide oxygen for clean air. That's why I dig fruit trees. And I'm planting alongside Vitafusion Gummy Vitamins and the Fruit Tree Planting Foundation to plant 200,000 fruit trees, generating 28 million pieces of nutrient-rich fruit and 33 million pounds of oxygen, so people can breathe easier, improve the soil quality, and make a positive impact on our planet for generations to come. Visit WeDigFruitTrees.com.
And that's Viewpoints for this week. Viewpoints is a production of MediaTrax Communications. You can follow us on Twitter and Facebook to learn about upcoming shows and find a library of past programs on iTunes. Plus, you'll always find podcasts of our segments and information about our guests at viewpointsonline.net. Join us again next week for your public affairs magazine, Viewpoints.